district. So I migrated to Singapore in 1992.
Oh, okay.
I studied in CET, then Delhi IIT.
Oh, I'm an alumni of this college, sir.
Altaf, your master's was in geotechnical or something else?
My master's in rock mechanics.
Rock mechanics. Okay, that's why I remember, because we are actually offering one elective of rock mechanics to students.
Oh, I see.
But you know what happened? There are only few people who are specialized in rock mechanics.
Yes.
We couldn't get sufficient experts in rock mechanics actually to set the question paper for university examination.
Oh, I see.
Even in CET, I don't think even in CIT, nobody is specialized in rock mechanics as of now.
I think only among the IITs also, I don't know whether other IITs offer rock mechanics.
Earlier, Dr. Balan was there, but he retired. I think Balan was also from IIT Delhi.
Oh, I see. Yeah, rock mechanics now got a lot of applications. All this tunneling, all those things that involves rock mechanics.
In my opinion, that is a rare subject. Not much people are masters in rock mechanics.
Sorry?
I believe rock mechanics happens to be a rare specialization.
Yeah, it is just one of the, just like geotechnical engineering, environmental. This is just another specialization, rock mechanics. So it's a part of geotechnical engineering, but more focused on the rock.
Altaf sir, shall we start?
We can start. Yeah.
Good afternoon, dear participants. We have come to the last session of the day, and this session will be handled by Engineer Altaf Hussain. He's Senior Project Manager at CNC Holdings Singapore, and he will be taking the topic Supervision Guide of Deep Foundations. He's an individual with vast industrial experience. Without much further ado, I welcome Engineer Altaf Hussain sir to handle this session. Thank you, and over to you, sir.
Thank you, Engineer Nirmal Joy. Good afternoon to all of you. At the outset, let me thank Dr. Ribu Sakriakoshi for inviting me for this lecture. And also, actually, I know Dr. Ribu Sakriakoshi for many years, more than 30 years, and his wife, Dr. Anita Joseph. Okay, basically, I'm from Kerala. I'm from Pattanapuram, Koilon district. I studied, my schooling was in St. Stephen's High School, Pattanapuram. Pre-degree at Marivanis College, Trivandrum. Engineering degree from College of Engineering, Trivandrum, CET. And a master's degree in rock mechanics from IIT Delhi. Prior to coming to Singapore, I started my career as a lecturer in civil engineering at Crescent Engineering College, Chennai. I understand it's a deemed university now. In fact, I was the first faculty member of civil department of Crescent Engineering College. And also I have worked in Ministry of Water Resources, Government of India, at the Central Soil and Material Research Station, doing geotechnical investigations, research for river valley projects, all those things. Okay, so today my presentation will be based on my involvement in projects in Singapore. So right from this is my 30th year in Singapore. So right from my first year in Singapore, I have been working in the foundation, ground engineering field. So I had the opportunity to do all types of foundations. So today the topic is a supervision grade of deep foundation. So deep foundations, mainly it is a piled foundation. So the pile foundation, actually, there are different types of pile foundation, depending upon the method of insulation, depending upon the materials used, and also depending upon the function. So here, initially, I'll be giving you an overview of the different kinds of pile foundation. So for that, I'll be using my project involvement. I'm using the pictures of the projects, the structures which have been erected in Singapore. So first one of the most challenging projects I have done in Singapore is a marine work. So this marine work, it's called the Changi Naval Base. So this naval base was constructed for the US. So it's a US naval base. This is marine piling. So you know that there is a land piling, mostly is a land piling we are all very familiar with. So in this Changi Naval Base, it is a marine piling, and here different types of piling was involved: sheet piling, steel pipe piling, spun piles, precast. So the first three, they are the piling, the foundation part, and so the overall structure comprises a precast deck structure also. I'll show you some photographs. So here, this is a simple layout of the thing. So here, see, this is a structure I was involved in. So this is called a breakwater. This was called the West Breakwater Pier, then the South Breakwater Pier, and there's a breakwater. So this is a 2.6 kilometers into the sea. It is starting from the land. It is going all the way 2.6 kilometers away from the sea. So in this kind of construction, marine constructions, see, this is a finished structure. This is the West Breakwater Pier, then here the South Breakwater Pier, and here the curved portion is a South Breakwater, which is a 2.6 kilometers into the sea. So I told you this was constructed for the US. So already it was commissioned in 2000. Already the US ships are all using it. So, and also together with this project, there was one beacon. So this is called the Frontier Beacon. So this was constructed 3 kilometers from the shore. And this is supported by 4 pipe piles, steel pipe piles. So for all these marine structures, all the construction is done from floating barges. So here you can see a photo of a floating barge, and this is see, there is a crane also there. So crane barge, and also you can see the material. The material there, these are spun piles. Spun piles are reinforced concrete piles. Later I'll show you some section Now, some of you may be familiar with all these piles, all those things. For the benefit of those who are not familiar, I will show you some pictures. Okay, this one, the pile driving. Pile driving, there will be some temporary staging for the access, all those things. And the driving is basically using vibro hammers. So there are vibro hammers of different capacities, 7 ton, 12 ton, 15 ton. So depending upon the size of the pile and the depth you have to achieve, you'll be choosing the vibro hammer. See, these are steel pipe piles. Before driving, the steel pipe, so they are tubular sections. So see, the piles are basically based on materials. There are two classifications. One is steel pipe, steel, and another one is reinforced concrete. So reinforced concrete also, there are precast piles as well as cast in situ piles. So these are pipe piles before driving, and here you can see these are the piles driven in the sea. These are the spun piles. Just now I was talking about spun piles. So the spun piles also, they are also tubular. There's a hollow portion at the center. So the spun piles are called spun piles because the manufacturing involves spinning. Why spinning? Because you see this wall is a very thin wall, and it is also reinforced in order to make sure that the concrete is properly compacted inside. So the manufacturing is done by spinning it. So during the spinning, the concrete, so that there are no honeycomb, nothing inside, we get a very sound, compact concrete. So that is the reason why it is called spun piles, manufactured by spinning. So the spun piles are usually at the toe, there will be steel shoes, because all these precast spun piles, insulation is will be driving it into the ground using very heavy hammers. So in order to facilitate penetration through hard stratum, there are shoes at the bottom. So the first section, so usually this come at sections of 12 meter, 6 meter, like that. And after driving the first section, we have to join the next section by welding. Then we'll continue the driving until the toe level is reached. So the depth of how much we have to penetrate into the ground, that depends upon what is the load it is going to carry. So you know that piling, there are two components. How the pile capacity comes from two factors. One is the end bearing and the other one is the skin friction. So the skin friction, that is the periphery of the area of the pile when in contact with the interacting with the soil, there is a skin friction. Then based on at what level, what kind of stratum it is founded, there will be an end bearing also. So the depth of the pile, the size of the pile, all these will be decided based on what kind of loads are going to be taken by the piles. Okay, then there are steel sheet piles. This is before driving and this is after driving, steel sheet piles. So the piles are based on the function, also there's a classification. One function is as foundation piles. So these spun piles, bow piles, steel pipe piles, they are basically for carrying a load as a foundation pile. Whereas the sheet pile, this is usually a retaining structure. It's a retaining structure, or it will act as a fender wall in water. In retaining on land, it will be an earth retaining structure. Okay, these are some of the photos. These photos, see 99 during the construction. So here you can see the barges, the crane barge, and the floating barge, material barge, all those things. Here you can see the spun piles here, and here we have the sheet pile, and this is a portion of the barge you are seeing in the photo. So these are just some photographs during the construction. These are all spun piles, and these are all temporary structures for facilitating access onto the pile for working. So this is see, above the pile there'll be a pile cap. So the pile cap construction, then followed by there'll be a deck structure. So the deck structure was all precast units. So the precast units were brought from Malaysia, Indonesia at that time. So all the transportation is by barges. So the barges will be propelled by tugboats. These are all some photos during the construction of the Changi Naval Base. Okay, this Changi Naval Base, when we started, in the beginning, the first month or so, there was an unprecedented high tide much higher than usually expected, and a portion of our construction collapsed into the sea in the beginning. See, here you can see a portion of our construction. Initially it collapsed into the sea. You can see these are fender walls. Then it necessitated a rescue operation, first thing to recover all those things, take out. Then we had to do a redesign and launch it again. But despite this unfortunate incident, we were able to finish the project on time. So these are all rescue efforts. Okay, so here, since we are using steel pile, the pipe piles, all those things, the pipe piles were sandblasted and coated, done coating, because this is all seawater, the steel can undergo corrosion. So, to prevent that, all the steel pipe piles, all those things were sandblasted and they were coated. There was a particular paint coated so as to prevent or mitigate the corrosion. And also, about the cathodic protection system. I don't know whether you have heard about the cathodic protection system. So the cathodic protection system, that is also for mitigating the corrosion. So in that we install an anode, so that instead of the pile material corroding, the anode will be corroding off. So actually this was a very, very interesting project. It was about 88 million project. So this is a marine project involving marine piling, different types of piling. Another project I have involved is a Marina Bay Sands. So this is a recent one, I think within the last 10 years or so. So this project, it has a diaphragm walls and board piles. Just now I told you, based on the function, the these ground engineering structures can be divided into two based on the function. So in this case, the diaphragm wall is a earth retaining structure, and the bore piles, they are the foundation piles. This is a Marina Bay Sands, so it comprises three 50-story buildings with a roof garden. So here the bore piles usually the sizes vary from 500 mm diameter to 3 meter and plus. So here the Marina Bay Sands, it involved pile diameter up to 3 meters. And also the depth goes to about 60 meters, 70 meters like that. So all this depend upon the column loads, how much load need to be carried by the column. So the pile layout, the sizes and numbers, all these things will be designed based on all those load combinations. So this is a Marina Bay Sands. So this is a resort kind of thing. A lot of international events all take place here. So I told you this Marina Bay Sands involves a diaphragm wall. So just I'll give you some pictures of this diaphragm wall. So diaphragm wall is involved when there are basements. See here, it is a 50-story building, three 50-story buildings with a roof garden, and there are basement usually for the car parking. So there will be basement up to 5 levels of basement. That means we are going beneath the ground, 5 levels. So these are all the basement. So basement, before we can excavate the basement for construction, the boundary of excavation, you'll be installing the diaphragm walls. So diaphragm wall basically comprises panels, reinforced concrete panels. So it will be constructed by panel so as to bound the whole area of excavation. So if it is say five basement, the diaphragm wall depth, depending on suppose each basement is say 5 meters. So the diaphragm wall, say 5 into 5, 25 meters, plus it has to go below the last basement. So it is basically, it is a earth retaining structure. See, these are all pictures of diaphragm wall. This is a diaphragm wall. Okay, another prestigious project I had involved is Jewel, the Changi Airport. Changi Airport, it is one of the busiest airports in the world. So recently, a building Jewel was constructed. So this is the Jewel. So this was constructed concurrently when all the flight operations were going on, because no operation can be stopped for the construction, and also the area around the Changi Airport is a very congested, busy traffic all the time. So lot of traffic diversions all had to be done for this one. So this project, the Jewel, involves 5 basements and also 5-story. This is a control tower of no, this is inside the Jewel, the fountain inside the Jewel. So it's it attracts a lot of tourists all over the world. This is a SkyTrain track. So here it is basically diaphragm wall and bore piles, and there were contiguous bore pile wall also. So diaphragm walls, I told you, there are concrete panels, and bore piling is for foundation. Then this contiguous bog pile wall, that's also is another ERS, earth retaining structure. So the contiguous bog piles involve bog piles installed continuously with a small gap. I will show you a photo. See, this is a contiguous bog pile wall. So this contiguous bog pile wall, this is a kind of earth retaining structure. So in there's a jewel project for the 5 basements. The area for excavation was bounded by diaphragm walls, but this contiguous bog pile wall was used for the car park ramp. The car park, see the ramp going up, down. So those ramps, the earth, the side earth was retained using the CBP, contiguous bog pile wall. So CBP installation, there will be a small gap, usually about 100 mm gap between the piles. So this 100 mm is required for construction purpose because in bog pile wall we have to install a steel casing. So it cannot be touching each other. There should be a small gap, and usually the gap is about 100 mm. And subsequently this gap will be plugged using shotcreting or a skin wall, because see this earth retaining structure, apart from retaining the earth, it has to stop water flow, all those things, the groundwater, seepage, all those things. So it has to be watertight as far as possible. So this is also CBP, contiguous bog pile wall. Then another project I had involved is the police cantonment complex. This also involved diaphragm walls and bog piling. Okay, I'm just showing some typical projects so as to introduce different kinds of piling. So this is another project, Woodlands Police HQ. Here it is the ERS, the earth retaining structure, is a secant bog pile wall, and the foundation is a bog pile, foundation bog piles. So secant bog pile, it is somewhat like a CBP, contiguous bog pile wall, but there's a difference. Secant bog pile wall, see in CBP, the piles are installed at a spacing of, see the gap is only about 100 mm. In secant bog pile wall, there are 2 types of piles. One is a primary pile, this one. Then we have the secondary pile. So if you notice, the secondary pile got reinforcement cage, whereas primary pile, there is no reinforcement. So primary pile, secondary pile, we also call it soft pile and hard pile. So this soft pile will be installed first. Then we will be cutting through the soft pile to install the hard pile. So in this case, there is no gap. The wall we are producing, it is without any gap. So usually the concrete grade used for the soft pile, this is soft pile, the grade will be much lower than the hard pile. So the concrete grade used for the soft pile, it is usually grade 15 or below. And the hard pile, it will be grade 30 and above. So you know what is grade 30 means 30 megapascals, 30 Newton per millimeter square. So this is a secant bog pile wall. Okay, another project I was involved is the King Center development. This its foundation is all steel edge piling. Steel edge piles before installation. So it has the shape of H. That's why they are called steel edge piles. So this is after driving in. Another project is a New Woodlands immigration checkpoint. Here the foundation is a spun piles. So you have already seen the photos of spun pile there. Reinforced concrete precast piles. So I'm showing you all these photographs just to have an idea about the type of piles and the sizes of piles. You look at the number of stories, all those things. So when the number of stories more, so the column loads will be more. So we need to provide for bigger piles with deeper penetration. And then there's yet another deep foundation which is a micro pile. Micro pile is a very small diameter pile. Is around 250 millimeters to 300 millimeters. So this is a small residential building. There are 3 stories and there is a 1 basement. So that's why the basement, the earth retaining structure is sheet piles. Then the foundation is micro piles. These are some photographs of micro piles. It's usually about 250 mm or 300 mm. Is a heavily reinforced. So micro piles are generally, when you look at this, are more expensive also because they're heavily reinforced. So that's why you go only up to 300 mm. So if the column loads exceed what can be carried by a 300 mm micro pile, then we go for the bow pile. Bow pile is only 500 mm diameter. So this is a micro piling rig. It is much smaller compared to a boring rig. This is a boring rig. So Kerala also, this land piling, you must have seen all this machinery. And Chennai, they are doing diaphragm walls. I don't know Kerala whether there are any diaphragm wall construction. But I know Chennai, the metro, they are doing diaphragm walls. Okay, so the diaphragm wall use a grab for the excavation because these are rectangular panels. So what is used is a grab. These are just some photos of the crane barge. This is a crane barge, and this is a boring rig mounted on a floating barge. So this was used for on Seletar link bridge, where one bridge was constructed in a reservoir. And then the micropile rigs are sometimes the micropiles are used inside the building also, for the purpose of underpinning, strengthening, all those things. So in such cases, we'll be using a very low headroom rig. So this is an example of a low headroom micropiling rig. So the rig can go inside the building and do so. Usually, it is used for strengthening the existing buildings, all those things. So this is an overview of the different types of piles, deep foundations. So you have seen the piles can be classified based on materials, reinforced concrete piles and steel pipe piles. Then it can be classified depending upon the method of installation. Depending upon the method of installation, there can be displacement piles and non-displacement piles. Displacement piles, from the term, we can understand that when we are installing the displacement piles, there will be displacement of soil around. And the non-displacement piles, it is basically will be boring the soil out. Then the soil will be replaced with concrete and steel. So the non-displacement piles are also called replacement piles because we are replacing the soil. We are drilling out the soil, then we are replacing it with concrete and steel. So if you look at the different types of piles we have seen, okay, micro piles, it is a non-displacement pile because we are drilling out the soil, then replacing with the concrete and steel. If you look at sheet pile, it is slightly displacing because you see the cross section. So the how much it displaces, that depends upon the cross section area of the pile. So sheet piles, it displaces very slightly. Spun pile, it is a significant displacement. You are driving, you have seen the circular section. There is a hollow part inside, but still there is a displacement because of the area of cross section when you are driving into the ground. This is also driven pile. So here also, compared to a pipe pile, H pile, the displacement is less because of the section, the cross section area. So displacement and non-displacement pile. So this is an overview. Now I will go into the supervision guide. Okay, before we start any project, the first thing is we need to have a set of approved drawings showing the layout of the piling. So this piling layout, that will show all the, shows setting out. It will be set out based on the vertical and the horizontal grid lines. And the complete information will be there in the piling layout, how to set out a pile, because the location need to be, cannot go wrong. Then we have the sizes, then the penetration, what is the required penetration, all these things will be in the drawing. So there should be the latest set of drawings at the site. So this is very, very important, because sometimes if the site is not provided with the latest drawing, if the installation is carried out based on superseded drawings, that has got a lot of consequences: cost, time, also quality. See, any construction project, the four most important vital aspects of a of a construction project, there are four things. One is cost, next is the time, then the quality, then safety. So these are the vital aspects of a construction project. So these four aspects need to be controlled well. So this documentation, updating the drawings, all those things, that is very, very important. Another aspect is underground services. See, in Singapore, all the services are underground: pipes, cables, pipeline, the sewer line, water pipes. So usually all these things are within 1 to 2 meters. So before we start any excavation work, piling, boring is an excavation work, or if you're driving also, before carrying out any activity on site, the first thing to do is to we need to get the services drawing from the authorities. Because damage to underground services, the consequences are really, really very severe. Sometimes if you go and hit a service, it can lead to severe injury or even fatality, apart from all the property damage. So it's very important to make sure that before we start any operation, any digging operation, boring operation, or driving operation, we need to get all the services drawing. So what are the services? Are there any services clashing with the proposed piling points? See, if we go and hit an electric cable, it can lead to explosion, it can lead to electric shock. Then there are gas pipes, leakage of gas pipe also can lead to fire, explosion. It's just a photograph. Water pipes, if the water pipe is burst or whatever, see, Singapore is a very, that there are so many buildings, it's a very crowded city. So if any of these things happen, the consequences will be really very, very severe. So we have to ensure that before we start any digging, driving in, or boring in, we must ensure that whatever activity we are doing is away from services. Sometimes the damage can be very, very expensive also. See, this is an example of flooding in the road, or flooded because some water pipe or something damaged during the piling operation. Aftermath of a gas explosion. So even driving in a steel road, even that can also damage the services. So it's very important, and especially nowadays, there are many mobile service providers like a SINGTEL, M1, StarHub. All their cables are underground. If you go and hit one cable, the city area or anywhere, the mobile service will be affected for a few hours. And if you go and damage this kind of cables, the penalty is about $1 million. 1 million, if you convert to Indian rupees, is about 5 crores. Because the consequences coming out of such damage, that is really severe. Lot of operations will be affected. And in Singapore, actually, all these we never. I'm in Singapore for 30 years. I have never come across any incident of no power. It is always there. So Singapore has its own reputation for so many things. So any of this disruption, that is very, very, you will end up in jail. So how do we prevent damages? So we have to look at the services plan, and we have to look at our piling plan. Then we have to closely check to see whether there are any services in our area of work. And also there will be some signs like a telecom box, then some other markers on the ground showing there are underground services beneath. So these are some typical drawings like a SP Power, Singapore Power, the services layout. These are PUB, Public Utilities Board, sewerage plan. This is a water main. So before we commence a project, usually we have to engage a LCD, that is licensed cable detector. So based on all it, sometimes these drawings also may not be accurate. So sometimes we really have to manually make trial holes and to see where exactly the service. So if the service, if they are clashing with our piling points, there are two options. One is to relocate the pile, another one is to divert the service. So in some cases, we may not be able to relocate because the design requirement, as per the design requirement, the location has to be at a particular point. So if that point has underground services, then we have to apply for diversion of services away from our area of work. So this is an example of trial trench, this is a sewer pipe. So this has to be dug manually, because if you go and use excavator or those things, if you go and hit the thing, then big problem. So the trial trench need to be done manually to see the exact locations. So in some cases we have to protect. Suppose we are going to do the pile installation very close to the services, then we have to protect the services so that during our piling operation the services are not damaged. And also after doing the trial trenches, after we cover the trench, backfill the trench, we need to put some signage there showing what cable, how deep, all these things. Because on site, sometimes different people, there may be changes in site personnel. So when they come in also, they should be able to see all these things. Okay, now I told you based on the method of installation, there are two types of piles, non-displacement piles and displacement piles. So now we look at the non-displacement piles. So in non-displacement piles, the soil is removed and then the boat hole is filled with reinforced concrete. So this is a boat cast in situ pile. So here you can see this is a boat pile, and here you see starter bars. So the starter bars, these are for connecting with the pile cap. So here there will be a pile cap, then the pile cap, the columns will be constructed. And these are barrette piles. See, these are circular bow piles. The barrette piles are rectangular shape in cross section. In cross section is a rectangular. So here also it is cast in situ. So they are called the barrettes, rectangular cross section. So the quality control. So the various aspects of quality control is a temporary steel casing. When we are doing bow piles, first we do a temporary casing. So the temporary case, because the temporary casing That will be one thing. It will be a guide. And second thing, see, the top soil will be soft soil. So to prevent the collapse, there should be a temporary steel casing. So during the installation, you have to check the pile verticality and the base. Then in piling, bow pile, there are two methods of concreting. One is dry method and the one is tremie method. Then you must know what is the soil strata, what is the final depth based on drawings. Then the steel reinforcement also, details of the steel reinforcement from the drawing. So the steel reinforcement, see, piles also, some piles are just compression piles. So compression piles, the steel reinforcement may not be full length, whereas tension, if the piles are subjected to tension, then the tension piles reinforcement will be full length. Reinforcement has to be there until the toe of the pile. Then the concreting, then usage of support fluids. Support fluids is basically, to prevent collapse, you'll be using supporting fluid like a bentonite, polymer, all those things. Okay, about temporary steel casing. So why do we need temporary steel casing? So it's a temporary stabilization for drilling works through soft, weak, or unstable ground. So it will avoid, see, this is a temporary casing. It will avoid the soil from collapsing into the borehole. And also, this will be a guide for the drilling auger head, this temporary casing. So usually the minimum temporary casing is about 5 meters or so. So this temporary casing, and also it mitigates the something called the overbreak. Overbreak is, see, suppose we are intending a 1,000 diameter pile. So this is an actual 1,000 diameter pile. But sometimes because of soil conditions, some areas the hole may be bigger than 1,000 mm, like this. So this is called overbreak. So overbreak, this area, the skin friction is affected. So the strength, the capacity of the pile is affected. And also this leads to a lot of concrete wastage. If the hole, if the intended diameter is 1,000 and some section, if the diameter is more than 1,000, we end up wasting concrete. That is money. Okay, this is a temporary steel casing. So usually you have to keep 1 meter, keep it 1 meter above ground level for safety consideration. There are instances whereby people have fallen into the borehole. 30-meter, 40-meter borehole. During the rebarkage installation of, during some operation, there are incidents whereby workers have fallen into the borehole. So once they fall in the borehole, that's it. We cannot rescue. So it's a safety requirement that the temporary casing need to be at least 1 meter above ground level, and into the ground it will go at least 5 meters. Then depending upon soil condition, the temporary casing length can go up to 12 meters. Sometimes even 12 meters also we cannot prevent collapse of soil. So then we may keep on extending to 15 meters, 16 meters. But longer the temporary casing, it will take more time, and our productivity will be adversely affected. So we have to look at the soil conditions and decide on what should be the length of casing to be used. So usually before starting any project, I will be doing some trial boring to see what is the soil condition, what is the temporary casing required, all these aspects. So the temporary casing also, we must have, after installing, during installation, we have to check the verticality, because the pile, there is a tolerance limit of 1 in 75. So we cannot exceed the verticality tolerance. So after concreting, the steel casing will be extracted. That is why it's called a temporary casing. The steel casing will be extracted using a vibro hammer. So the extraction need to be done carefully at a steady rate, so as not to, because the concrete just green, it is not properly set or hardened. So we need to extract the casing carefully at a steady rate. So these are just some photographs of the steel casing extraction. So it can be extracted using a vibrator, using a crane. Then some boring rigs they have the rotary head. So this rotary head, using the rotary head, we can install and extract casing. In some areas, the vibro hammer may not be allowed, because if you are doing pile insulation very close to existing buildings, all those things, and some are sensitive buildings. In such buildings, there is a vibration threshold. You cannot exceed the vibration beyond a certain limit. So in such cases, because vibro hammer, that creates a lot of vibration. So in such cases, we will be using a boring rig with a rotary head with a casing adapter, so that the machine itself can drive in the casing and extract the casing. Okay, pile verticality. So the piles are designed to be vertical. So because basically the piles they have to take the compressive force and the concrete good in compression. If the pile is non-vertical, then tensile forces will be induced into the concrete, and the concrete cannot take tensile forces. So the pile verticality, it is very important. So usually the tolerance is 1 in 75. That means for every 75 mm vertical, the allowable horizontal deviation is just 1 mm. So pile verticality at all stages need to be monitored. So right from the beginning, when you are starting the boring, when you are positioning the auger, you have to make sure that it is central to the casing. First thing, the casing should be installed vertically. You have to check the verticality. Then when we are starting the boring also, we need to ensure the verticality. So the verticality is monitored using spirit levels. So using the spirit level in both direction, we have to check the verticality. And the machine, the boring rig itself also got a kind of a bubble, the spirit bubble inside. So the machine also should be adjusted to make sure that the bubble is at the center. The Kelly bar all vertical, truly vertical. So for dry piles, using a mirror also we can check the verticality, whether we can see the toe from the top by reflecting the sunlight or using a torch. This is applicable for dry piles. So if the pile inclination is greater, then the QSS has to consult QP. QSS is the quality site supervisor. So quality site supervisor, basically they are resident engineers and resident technical officers. So resident engineers are engineers graduated from recognized universities. For your information, in India, only very few institutions are recognized in Singapore from India. Even CET, Trivandrum, CET is not recognized. I got accreditation as resident engineer because of my IIT degree. So QSS is a quality site supervisor. QP is a quality person for every project. There'll be a quality person who is a professional engineer. So there'll be basically one QPS and QPD. QPS is quality person site supervision, and QPD is a quality person design. QPD. So this is ensuring a clean toe. After boring, before we install the reinforcement cage, we have to ensure that the toe there is no soft toe. So for that, a cleaning bucket will be used to thoroughly clean, so that before we place a reinforcement cage and concrete, we clear all the slurry, everything from the pile. So it's a very clean. It has to be clean so that it doesn't get the slurry get mixed up with the concrete, which will affect the integrity of the pile. So these are all about the base, quality of the base. Okay, then I told you there are two methods, dry method and a tremie method. So dry method is faster. So dry method is possible when the soil stratum, we have very firm soil. There's no collapse of soil. So in this case, we'll be just boring and placing the reinforcement cage, then pour the concrete. But in some cases, if the water table is very high, we cannot do dry method. Even after installing the casing, when we are boring deeper, water will be percolating, seeping into the borehole. So in such cases, in order to stabilize the borehole, we'll be pouring in stabilizing fluid. So the dry drilling is suitable for very stiff to very stiff, medium dense soil, suitable only for deep groundwater table. So in tremie method is suitable for all kinds of soils. So we have to use supporting fluid, which is usually is a bentonite or polymer. So density of this bentonite or polymer solution is more than that of water. So it will be supporting the borehole. So this bentonite or the fluid polymer, there are some criteria on the viscosity, sand content, all those things. So in order to make sure that the borehole stability is ensured, these properties will be tested on site. So this is a tremie concreting. So for the tremie concreting, why it is called tremie? Because we'll be using a tremie pipe. So the tremie pipe will be lowered up to the toe of the borehole, and so the borehole is filled with the fluid. Then when we are pouring concrete through the tremie pipe, the concrete will be displacing the fluid up, and there will be a material put which is called the vermiculate. It will create a membrane between the fluid and the concrete, so that when we are displacing like this from below, we are displacing the fluid with the concrete. The tremie pipe is lowered up to the toe of the pile. Then we are pouring concrete from the top of the tummy pipe. So the concrete reaches the bottom, then it displaces the fluid up and it will be discharged out. So when you're boring a hole, so every 3 meters we have to take out samples, soil samples. And they will be kept in plastic covers for future reference. Because all the pile design, they are all based on the borehole data, the closest borehole data. So the design is based on that. So the actual on site also, they have to be closer to those descriptions. So if it's different, then we may have to review the pile depth. So this is a final depth confirmation. So using a tape, so the tape at the end of the tip of the tape, there will be a metallic piece so that just by feeling, when it is touching the base, just by feeling the base, we can feel the base using by touching the base with the metallic piece at the tip of the measuring tape. Okay, then after the toe level is confirmed, you have to lower the rebar cages inside. So these are all rebar cages. So all these rebar cages are based on the designs. So the rebar cage, all the detailing will be in the piling layout plan. So as I told you, for compression piles, the length of the rebar cage will be specified in the drawing. For tension piles, it will be all the way down until the toe. There's some pictures of the reinforcement, and also when usually the rebar cages are fabricated in 12-meter lengths. So if the pile depth is say 30 meters, then we have to use more than one cage. So in that case, we need to do lapping. And this lapping, there are two ways. After lapping, we can do welding or we can use the clamp. It's called the U-bolt. So this is a U-bolt. The rebars will be clamped together using the U-bolt. Another way is welding the rebar. But the welding is a time consuming. So for productivity purpose, we always prefer using the U-bolt. And these are the spacers, plastic spacers to ensure to achieve adequate concrete cover. So usually the cover required is 75 mm. There should be a minimum concrete cover of 75 mm from the reinforcement. So this will be the consequence. If there is no cover, concrete cover, the rebar will be exposed. So rebar comes into contact with the soil and it may deteriorate, then the pile quality is affected. So using the spacers to achieve the concrete cover, that is very important. And also lifting the 12-meter cage and installing, there are safety aspects to be followed. There may be nearby structures, there are personnel around, so there should be a lifting plan showing how we are actually lifting and installing the rebar cage, ensuring safety. Okay, the concreting. So compared to concreting for superstructure, other structures, pile concreting should have some unique qualities. So it should displace fluid, and it should be self-leveling, because we are not using vibrator, all those things to compact. So it should be self-leveling, and it should flow around the reinforcement cages. See, when there are congested rebar cage, all those things, the concrete should flow into all the portion. There should not be any honeycomb or any cavities or inside the thing. So for the concrete, for the workability, a slump will be specified. A slump. The slump will be tested using at the site before we actually place the concrete inside. Now to ensure it can flow, it is self-leveling, and also concrete is placed using tremie pipe so as to avoid segregation of concrete. So these are all, if you don't pay attention to all these things, the integrity of the concrete of the pile will be affected. So this is a tremie pipe. Even if it's a dry pile, we have to use a tremie pipe, a hopper, and a tremie pipe. And this distance from the top of the concrete, height from the top of the concrete or from the toe, it cannot exceed 3 meters. That means if the height is, if you are placing concrete from higher levels, the chances of segregation is more. So there is a specified, it should not exceed 3 meters. So it's just a photo of a concreting pouring in the hopper. Usage of support fluids. So I told you it can be either water, bentonite, or polymer, but water may not be effective most of the time. So we go for bentonite or polymer. And the usage of polymer is increasing. Because one thing is, so these are the reasons, comparison of bentonite and polymer. So polymer mixes instantly, whereas a bentonite requires 24 hours for mixing. Then the polymer can be recycled again and again, whereas bentonite restricted to 2-3 times. Then bentonite, sand content is a problem in bentonite. So the sand, that affects the concrete strength. Environmental, this polymer is a biodegradable liquid. So disposing of a bentonite needs treatment before disposing of, whereas a polymer is a biodegradable because it will break down its own. So these are just some details of the supporting fluid bentonite polymer. So this got a specification. So before commencement, all these specifications, all the documents need to be submitted for approval. These are the silos used for the storing of the fluid, the supporting, the stabilizing fluid, polymer or bentonite. They just polymer, bentonite, the plant, the circulation, mixing, and circulation. Okay, once a pile is cast, there should be a work pile record showing all the records. What is the starting of boring? What is the boring depth? What is the detail of reinforcement? And what time the boring started? What time the boring ended? Then the concrete. what time the concreting started, what time the concrete ended, and what is the volume, theoretical volume of concrete required, and what is the actual volume of concrete used. So using that, we can calculate the overbreak. So if the overbreak is too high, then we have to justify that the pile still is okay. Okay, during piling, environmental pollution control is very important. So here, authorities have specified the noise levels depending upon where we are doing. If we are doing very near hospitals, all those things, the noise levels allowed are more stringent. So we have to install noise monitoring, vibration monitoring, all those things before we start the piling operation. And there will be all this noise, vibration, it is continuously monitored, and periodically we have to submit it to authorities. These are all very important authority requirements. So noise also, if you exceed the noise beyond a certain limit, the contractor will get summons from the environmental agency. So the first time offense, $5,000, then it will increase to $10,000. If you continue, we will be summoned to the court. Then the vibration, you have to control the vibration. So always some threshold is set, cannot exceed those vibration limits, because there are buildings close to each other, and all these vibrations will create. See, this is an example. Adjacent building cracks on column due to excessive ground deformation. So we need to prepare a vibrating monitoring plan, and we have to comply with all the requirements. So for different types of the vibration limit is set for different kinds of buildings. These are noise and vibration meters around the site. So there is a requirement before we start any project, we need to do a pre-construction survey. That means before we start any excavation or any pile driving, the surrounding structures, we need to engage the specialist to do a photographic survey. So the purpose is to record all the existing defects. And later, when we are doing the piling operation, sometimes the existing defect, they may get worsened. So first, there will be a record. What was the situation before? What was the condition of the surrounding structures before we started the piling operation? So that is called the pre-condition survey report. So it involves a lot of photographs of the surrounding structures. So they will go inside and they will take photo of all even the minor cracks, everything they will take. So this will be a record as a base, so that future any complaints can be addressed based on that. So there are PCA guidelines. See, when we are doing piling operation, so if suppose we are doing it here, so if it is non-displacement piles with a small displacement, you see H pile or micro pile, small displacement, the pre-condition survey need to be done within 10 meters of the development. So here the displacement is not so significant. So you see it's a micro piles or steel H piles. Landed development. Landed development means bungalows, semi-detached terrace houses, shop houses, all those things. That is a landed development. This is for displacement piles such as RC piles, because RC pile it is a solid pile, so displacement is more. Jacked in steel pipe piles, see the area affected is more pipe pile, so the displacement will be more. So we need to do 20 meters. Earlier it was 10 meters, here is a 20 meters. We need to do a precondition survey. Okay, this is for non-landed development. Non-landed development is basically a flats. So here, see, we are developing here. There are so many flats nearby. So in this case, the area for precondition survey is 40 meters all around the proposed development. So the earlier one was a small displacement. This one more displacement, spun piles, steel pipe piles. So there is a 60 meters. So despite all these things, if there is any damage to the surrounding structures, then the contractor has to address it before proceeding further. So these are all good practices: environmental friendly, low noise, no vibration. So this involves thoughtful planning of the activities, and the use of what kind of machinery so as to mitigate all these noise, vibration, all those things. And usually the boring rig, there will be noise barrier panels installed to mitigate the noise. And in some cases, the noise barrier will be erected around the working area, noise barrier. Then the type of machine used, that also can affect the noise and the vibration created. So earlier the driven piles, it used to be percussion. That means dropping a 15-ton hammer or 7-ton hammer on the pile. So that was very noisy. So currently they are replaced with the jacking in piles, so that there is no noise at all. So the BCA, the Building Construction Authority of Singapore, every year they reward good contractors who are practicing good methods. Okay, then damages to piles already installed. After installing the pile, if you are doing nearby excavation, then there can be soil movement and that can damage the pile. Then when the site is in progress, sometimes especially the driven piles, they will be protruding above ground level. So if any crane or boring rig go and hit it, then that can damage the pile. Then during the hacking, see, after casting the pile, we have to hack the pile, remove the top portion, loose concrete portion, and we have to hack up to the cutoff level. So if you are using hydraulic breaker to hack the pile carelessly, that can also damage the pile. So all these factors need to be attended. And also during pile installation, after casting one pile, we are not allowed to install another pile within 5 diameter. That means if you are installing a 1000 diameter pile, the next pile we should not install within 5 meters. It should be away from that within the 24 hours, because the concrete is still fresh and not attain the required strength. So if you are boring very close, it will affect the concrete integrity of the concrete. So far we are talking about the non-displacement piles, and now we will go on to the displacement piles. So displacement piles are basically, they are all driven piles. So here you can see different types. This is a pipe pile, this is a reinforced concrete RC pile, and this is a steel H pile. So these are all precast and they are driven into the ground. So when you are driving into the ground, they will displace the soil around. So that's why they are called displacement piles. So these are all the pile driving machine. Pile driving machine, it has got a hammer, and the hammer will be dropping hydraulic hammers, dropping on the pile head until the pile is driven to the required depth. So the quality control of displacement piles, the various aspects is before driving the pile, during pile driving, then connecting or joining the piles, then after completion of driving, the quality controls to be enforced. Okay, prior to pile driving, any project, there should be a BCA permit before commencing work. BCA is the Building and Construction Authority of Singapore. So either it is BCA or LTA. LTA is the Land Transport Authority. So all the infrastructure, they are all controlled by the LTA. Then all other buildings is under BCA, Building Construction Authority. So all the drawings need to be approved by the BCA, the LTA as applicable. So the size of the piles, all those things, the piling plan, all those things, initially the consultant, they have to submit it to BCA for approval before that can be implemented on site, executed on site. So here also for displacement piles, also the verticality is very important. So check the verticality from both directions during the whole operation of driving to ensure that the pile is vertical and the verticality is within tolerance. So this also using a plumb, we can check the verticality. So always before starting the work, we have to submit a method statement, how we are doing different works. So method statement need to be approved by the relevant parties before we can start the work. So during the pile driving, so we have to notice the displacement, because especially RC piles, all there will be displacement. So this displacement can cause heaving of the ground. So all these things we have to observe. If there is anything serious, we have to stop piling and we have to investigate and we have to do the corrective actions. then the supervisor should ensure that the pile driving, it is because there will be some set calculations, all those things, specifying what should be the drop of the hammer, what is the weight of the hammer, all these things. So all these things need to be checked and ensure that there is a compliance. This is about the vibration. While driving vibration, the limits cannot exceed the limits. Then connecting or jointing piles. See, this is H pile. So H pile, the jointing around the pile is a butt welding. Then there will be a splicing plate. So there will be fillet welding around the splicing plate. Then after welding, there is a minimum cooling time so that before we resume the driving, the joint acquires enough strength. So this is a steel pile, this is a reinforced concrete RC pile, precast pile. So this is a jointing. So while joining also, we have to again check the verticality to ensure that after joining also, the next section is vertical. There's a vertical alignment is okay. Okay, this will be the RC pile after installing. So the RC pile, usually the termination is using the set. How we are able to, there will be a set calculation. So last 10 blows are how many mm? So this will be calculated using the Hiley's formula. So we have to drive until we achieve this, the final set for the 10 blows. In this case, just a sample sheet. For the last 10 blows, the penetration should not exceed 14 mm, and the temporary compression should not 14. So these are all calculated. What is the requirement? See, this is a Hiley's formula. This is a set calculation. Ultimate resistance of the pile. W is a weight of hammer. H is a hammer drop. E is a coefficient of restitution. P is the weight of the pile. S is a final pile penetration. And C is a temporary compression. So the final set and the temporary compression, they will be measured during the final driving process. This one graph sheet will be attached to the RC piles. It will be stuck to the RC pile surface. After that, a pencil will be held, and each draw, see, this will be formed at every blow. So it will show the set, and this will show the compression, temporary compression of the pile. Okay, so here also at the end of driving, you must have a record, the driven pile record. It shows what is the pile length, what is the set, what is the temporary compression, start time, finish time, all these things. So this is a piling record sample. This shows if it's RC pile, what are the sections used, how many meters, what is the total length, what is the ground level, what is the, see, all these details will be here. So this has to be verified, prepared by the contractor, checked by the main contractor, then approved by the QSS, resident engineer. So basically these are the things I have prepared for presenting to you, sharing with you. Now is already the time is. Hello, Nirmal.
Nirmal just left to finish a class.
Oh, I see, I see, I see.
So he actually wanted me to wind up the session.
Yeah, it's already
So
exceeded by.
okay.
Yeah,
Okay.
yeah.
I request the participants, if any one of you wishes to interact with our external person, it's a time for you now. Anybody? Any one of the participants? In case you don't want to discuss more with the topic, I will formally thank Engineer Altaf Hussain and wind the session up. As you know, for faculty development programs, especially funded by the Government of India, All India Council for Technical Education and the Indian Society of Technical Education, they make it mandatory that we include a certain minimum number of persons from the industry for the benefit of the participants. So what the academicians usually teach in faculty development programs are the basic things that are to be known to all practicing engineers. But when it comes to an industry person, we will get first-hand information about how they deal with practical problems in the field. Getting an industry expert is an extremely difficult thing as far as organizers of faculty development programs are concerned. And this time, we were fortunate to get a person with a vast exposure in a lot of geotechnical engineering works, especially relating to deep foundations. And we are extremely thankful to Engineer Altaf Hussain for the kind support he extended for the faculty development program. And Altaf has been cooperating with SAINTGITS College of Engineering in many ways in the recent past, and we are also thankful for that. And on behalf of the coordinators and on behalf of the Department of Civil Engineering and on behalf of myself, I extend a very hearty vote of thanks to Engineer Altaf Hussain. Thank you, Altaf. Thank you.
Yeah, thank you, Dr. Ribu. Thank you again for giving me this opportunity. It is really, I'm glad to share all this professional experience with all of you. I hope that it is useful to you, at least in some extent. And thank you, all of you. All the best to you. Thank you.
Thank you. Thank you very much. Now we are closing the session, and thank you very much.